Welcome back. Today we are dealing with salts. A salt is a compound formed from an acid by the replacement of hydrogen in the acid by a metal. For example, if we are taking an acid as HCl, that is hydrochloric acid, and replacing the hydrogen with a metal, say sodium, and you are getting a salt, sodium chloride, NaCl. It is also known as common salt. If hydrogen is replaced by ammonium group, that is NH4 group, ammonium chloride, NH4Cl is formed, and this is a salt. We have to notice that salt is a general name and it does not refer only to sodium chloride. In addition to sodium chloride, we have a large number of other salts too. Salts are formed when acid react with bases. And we know that this reaction is called neutralization reaction. The name of the salt consists of two parts. The first part of the name is derived from the name of the base, and the second part comes from the name of the acid. For example, the name of a salt called sodium chloride comes from sodium hydroxide base and hydrochloric acid. The salt of hydrochloric acid are called chlorides, and that of sulfuric acid are called sulphate, nitric acid are called nitrates, and salt of carbonic acid are called carbonates, and salt of acetic acid are called acetates. Now we can study some important salts and their formula. Sodium chloride, its formula is NaCl. Calcium chloride, CaCl2. Magnesium chloride, MgCl2. Zinc chloride, ZnCl2. Sodium sulphate, Na2SO4. Potassium sulphate, K2SO4. Calcium sulphate, CaSO4. Magnesium sulphate, MgSO4. Aluminium sulphate, Al2SO4 thrice. Zinc sulphate, ZnSO4. Copper sulphate, CuSO4. Ammonium sulphate, NH4 twice SO4. Sodium nitrate, NaNO3. Potassium nitrate, KNO3. Sodium carbonate, Na2CO3. Calcium carbonate, CaCO3. Zinc carbonate, ZnCO3. Sodium acetate, CS3COONa. Sodium acetate is formed by replacing hydrogen from acetic acid with sodium. Most of the salts are solids. They have high melting and boiling points. They are usually soluble in water, and the solutions of salts are good conductors of electricity, and they are called electrolytes. The conductivity of salts is due to the presence of ions in them. Salts are ionic compounds. Every salt consisting of a positively charged ion is called cation and a negatively charged ion called anion. As an example, if you are taking sodium chloride, it consisting of positively charged sodium ion, that is Na plus ion, and negatively charged chloride ion, Cl minus ions. Family of salts. The salts having same positive ions or same negative ions are said to belong to a family of salts. For example, sodium chloride and sodium sulphate belongs to the same family of salt called sodium salt because they both contain the same positively charged sodium ions in it. Similarly, sodium chloride and potassium chloride belongs to the same family of salt called chloride salt. What is the reason? Because they both contain same negatively charged chloride ion in it. Some of the important families of salts are sodium salt, calcium salt, magnesium salt, zinc salt, potassium salt, aluminium salt, etc. Next one, finding out the acids and bases from which a salt is formed. We are taking one salt as potassium sulphate. How can we write the chemical formula? For that we have to know the ions. Here potassium ion, that is K plus, and sulphate ion, that is SO4 2 minus. Writing their valencies at the bottom, that is valency of potassium is 1 and sulphate is 2. Crossing over, we are getting K2SO4 as the chemical formula of potassium sulphate. Now we want to find out which is the parent acid and parent base of potassium sulphate. For this, we have to hydrolyze the salt. Hydrolysis means splitting up of the compound, here salt, by the action of water. So K2SO4 plus water. We know that ionization of water you are getting H plus and OH minus. OH minus will move to the positive part of the salt, here K plus now, and forms KOH. How do we get the KOH here? That is K plus and OH minus. So writing valency at the bottom 1 1 each. So you are getting KOH as the formula. Whereas H plus will move to negative part of the salt, that is SO4 2 minus, and form H2SO4. How is that formula comes? That is H plus and SO4 2 minus. So writing the valencies at the bottom and crossing over, you are getting H2SO4. So the parent acid is H2SO4 and base is KOH for potassium sulphate. Next one, calcium sulphate. Here Ca2 plus and SO4 2 minus are the ions. Writing the valencies at the bottom, 2 for calcium and 2 for sulphate. So the formula is CaSO4. What will happen on hydrolysis of calcium sulphate? The H plus ion from water will move towards negatively charged ions of calcium sulphate, that is SO4 2 minus, and forms H2SO4. How can we get that? H plus and SO4 2 minus. Writing the valencies at the bottom 1 and 2. So crossing over, you are getting H2SO4. And the OH minus will move towards positively charged Ca2 plus ion and form CaOH twice. How is it formed? Ca2 plus and OH minus are the ions. So writing the valencies at the bottom, calcium, its valency is 2 and OH minus 1. So valency is 1. Crossing over, you are getting CaOH twice. So it's clear now. So we can say that CaSO4, calcium sulphate, is formed by the neutralization of CaOH twice and H2SO4, calcium hydroxide and sulfuric acid. Next one, sodium sulphate. Its formula is Na2SO4. Its parent base is NaOH and acid is H2SO4. Next one, magnesium sulphate, MgSO4. MgOH twice and H2SO4 are the parent base and acid which neutralizes to give MgSO4. Next one, copper sulphate. Its formula is CuSO4. CuOH twice and H2SO4 neutralizes to give CuSO4. Next one, sodium chloride, NaCl. The acid, the parent acid is HCl and parent base is NaOH. Next one, sodium nitrate, NaNO3. NaOH is the parent base and HNO3 is the parent acid. Sodium carbonate, Na2CO3. Sodium hydroxide, that is NaOH, and H2CO3, carbonic acid, is the parent acid. Next one, ammonium chloride, NH4Cl. NH4OH, that is ammonium hydroxide, is the parent base and HCl, hydrochloric acid, is the parent acid. The pH of a salt solution. A salt is formed by the reaction between an acid and a base. So we should expect that the solution of salt in water will be neutral towards litmus. The aqueous solutions of most of the salts are neutral in nature, which is having pH of 7. But some salts produce acidic or basic solutions when dissolved in water. We can see that aqueous solution of sodium chloride is neutral with pH 7. But ammonium chloride is acidic, which is having pH less than 7. An aqueous solution of sodium carbonate is basic in nature with pH more than 7. According to the nature of salt, they are classified into neutral, acidic and basic salts. First one, neutral salt. Its solution is having pH 7. They are formed by neutralization of strong acid and strong base. Let's take the example of sodium chloride salt. Sodium chloride salt is formed from a strong acid, hydrochloric acid, and a strong base, sodium hydroxide. Since sodium chloride is formed from strong acid and strong base, an aqueous solution of sodium chloride is neutral. It does not have any action on litmus. Another example of salt which gives a neutral solution is potassium sulphate. It is formed from strong acid, sulfuric acid, and strong base, potassium hydroxide. Next one, acidic salt. Its solution having pH less than 7. The acidic salt is formed by the neutralization of strong acid and weak base. For example, ammonium chloride. Ammonium chloride is a salt of strong acid, hydrochloric acid, and a weak base, ammonium hydroxide. So, an aqueous solution of ammonium chloride is acidic in nature. When ammonium chloride is dissolved in water, it gets hydrolyzed to some extent to form ammonium hydroxide and hydrochloric acid. The hydrochloric acid is a strong acid which is fully ionized and gives a large amount of hydrogen ions. On the other hand, ammonium hydroxide is a weak base which is only slightly ionized and gives small amount of hydroxide ions. Since ammonium chloride solution contain more number of hydrogen ions than hydroxide ion, it is acidic in nature. It turns blue litmus red. Another example of acidic salt is ammonium sulphate. It is formed from strong acid sulfuric acid and weak base ammonium hydroxide. Next one is basic salt. Its solution having pH more than 7. It is formed by neutralization of weak acid and strong base. Example is sodium acetate. It is formed by the neutralization of strong base sodium hydroxide and weak acid acetic acid. When sodium acetate is dissolved in water, it gets hydrolyzed to some extent and forms sodium hydroxide and acetic acid. The sodium hydroxide is a strong base which is fully ionized and give a large amount of hydroxide ion, and on the other hand, acetic acid is a weak acid which is only slightly ionized and hence gives a small amount of hydrogen ions, H plus aqueous. Since the sodium acetate solution contains more number of hydroxide ion than hydrogen ion, it is basic in nature and it turns red litmus blue. Another example is sodium carbonate. Sodium carbonate is a salt of weak acid carbonic acid, that is H2CO3, and a strong base sodium hydroxide. So an aqueous solution of sodium carbonate will be basic in nature and having pH greater than 7. That's all about salt. Hope you understand everything. Thank you for watching.